is the story of Willow Run, one of the Ford farms that virtually overnight became the largest aircraft plant that had ever been built. A story that now can be told in full. Here, before our security and freedom were challenged by war, boys were learning the trade of being productive and responsible Americans. They were taught to till the land and plow a straight furrow. Guided by farm experts, aided by modern machinery, the boys at the Willow Run farm planted, grew, and harvested the finest produce. Then came the threat of war. The sugar house, the maples in the farm were sacrificed to make room for a plant designed to produce one Consolidated B-24 Liberator every hour. Thousands of skilled workers were employed, pouring 100,000 yards of concrete, erecting 38,000 tons of structural steel, setting 10 million bricks, fitting miles of piping, and running more miles of electric cable to operate the thousands of machines that were to be installed in this truly giant structure. The Army Air Forces asked Ford to undertake mass production of this bomber, in addition to other aerial weapons produced by the company, which included troop-carrying gliders, turbo superchargers, and the 2,000 horsepower Pratt & Whitney aircraft engine. This 80-acre plant was built in record time. In reality, it was made into two plants under one roof, a manufacturing plant and an assembly plant. The now famous Willow Run Airfield covers 1,434 acres and provides 280 acres of concrete runways and taxi strips, enough to make a two-lane concrete highway 120 miles long. And this was Willow Run's product, a giant flying machine for which the plant was so carefully tooled that it could produce one every 55 minutes. This is the Army Air Force's Liberator Heavy Bomber, the ship that made headlines and was affectionately known among flyers as the Lib. This great aircraft is 110 feet from wingtip to wingtip and 67 feet 4 inches from nose to tail. Powered by four 1,200 horsepower air-cooled engines, the Lib can carry 10 men, 4 tons of bombs, and 5,000 rounds of machine gun ammunition at better than 300 miles per hour at high altitude. People flooded in the gates of Willow Run summer and winter, by day and by night. At one time, 42,000 of them. They made up the ranks of the bomber plant's production force. To teach these workers how, a $500,000 school was built adjoining the plant. More than 50,000 workers were graduated in from 1 to 10 subjects by this school organization. To do this vital job, Ford had to provide hundreds of instructors to teach more than 50 courses. Workers learned about the complicated aircraft hydraulic system and the mysteries of aircraft electronics. Cutaway engines served to illustrate installation and service details. Bomber and hour production made necessary the erection of a detached warehouse covering 11 acres to house and handle raw materials. In this vast space, 785 totally different items were stored. There were enough materials here and in the plant at one time to build 1,000 Liberators. Here you would find sheet aluminum, aluminum bars, coiled aluminum wire, and virtually every other known form of this lightweight metal, for 85% of a Liberator's 20 tons is aluminum. This was the first step of construction. Aluminum sheets were cut into proper sizes for handling in the plant's presses and forming machines, such as this great battery of presses which stamped out parts for the B-24. Some of these, the same presses Ford uses to make bodies and fenders for automobiles, were loaned to Willow Run. Because of the great variety of parts that go into a bomber, nearly 15,000 dies had to be constantly rotated through these presses to maintain a sufficient stock of parts on hand. This chart shows how Ford production men cut up the Liberator into major assembly sections. 1, the center wing. 2, the nose. 3, the aft fuselage. 4, the engines. 5, the tail, and 6, the outer wing. So it is with the final machining unit. Many machine operations were performed at the same time and in exactly the same position on every wing. This illustrates why every part of every Ford-built Liberator is exactly like every similar part, and shows why these parts have been interchangeable from ship to ship all over the world. Cranes fed the completely machined wings to twin furnishing lines, each of which was about a city block long. Here, women workers began installation of the incredibly complicated wing wiring system. As the bomb racks, catwalk, and bomb bay sides go in, you can see the fuselage take shape where it connects with the center wing. At this point, the nose section and the aft section of the fuselage were fed into the final assembly lines by being lifted to an overhead conveyor, which brought them to the proper spot for mating with the center wing. At this point, too, the great bird was ready to extend its wings. The bomber stopped on a floor conveyor and was slid sidewise to the middle of the bay. Note the little midget who will get inside the main wing to fasten the outer wing to the center section as it swings into position. The same action took place on the other side of the ship as well, and with both outer wings in place. The complete span is 110 feet from tip to tip. Here, the 4,200 square feet of bomber skin was cleaned. The woman worker polishes the bombardier's window. There is enough aluminum here to fabricate 55,000 coffee percolators, and it's quite a cleaning job. Back in 1941, it was believed impossible to build a bomber as big as the Liberator in an hour. In fact, in several hours. Even the conception of a plant such as this was viewed with considerable skepticism. Each of these machines is made up of 1,225,000 parts, and each had to be perfect. The Willow Run Bomber Plant has furnished one of the miracle production stories of this war. It produced 8,685 bombers in a steady stream, relentless, unceasing, on time, as methodical as a great river fed by its tributaries. And she taxis out to the runway for her first flight. The big ship gathers speed rapidly, racing down the runway for a full power takeoff. We're airborne and the wheels are retracted into their wing well. In the air, the belly turret is lowered and tested. Each of the 4 propellers is fully feathered. When the pilot readjusts the blades, the rush of wind will again start the engine. Bomb bay doors are open and closed. The flight engineer checks performance of the engines and equipment, including the inner communication system, after which the bomb bay doors are opened again and the dummy bombs are away. Test completed, our ship peels off. For the Army Air Forces, it has strength to fly and fight, and return to fly and fight again and again and again. That is its contribution to winning a peace.